All right. Microphone check. 1, 2. All right, let's check out what we got to do. Daily problem. Construct product matrix. Given a 0 index 2D integer matrix grid of size n by m, we define a 0 index 2D matrix P of size n by m as a product of matrix of grid if the following condition is met. What? Each element Pij is calculated as the product of all elements in grid except for the element grid Ij. This product is then taken modulo 1, 2, 3, 4, 5. Return the product matrix of grid. Product modulo. Let's see. So they give us a matrix grid of size n by m. And then they want me to make a new matrix. And each cell in this new matrix is the product of all the elements except for the current thing. So I gotta get everything. So this is like a mod question. I don't really know how the properties of mod work, but I think we can just keep multiplying every single cell and mod it. And then what? Then do we just divide by that cell? Let's see. Smart coder, what's happening? How you doing, man? All right, here we go. I'm iterating through every cell. And then I guess I want to take the product of everything. Program, what's happened? How long before you get those lids? I don't know how long they take to ship. Maybe a week or two, we'll see. All right, so every number is, every number could be quite large. So maybe, dang, should I cast something? Should I just make this a long, just to be sure? So if I did that, and then how, do I just divide? I don't know how mods work, man. So, all right, I'll make my vector P of size rows calls, and then it's basically just going to be every cell divided, prod divided by each cell. It sounds a little weird, but we'll see. And man, it has such a low acceptance rate. Man, I don't know. I think I should know how mods work by now, but I don't. And I don't know if I can just divide this by the cell to get the right mod answer, or if there's something else that's gonna be funky, you know? Like, I don't think this is it, man, but I will try just to see what's up. Right? Because, yeah, no way this can work. Let me think about this some more. Because there could be a case where everything, all the cells multiply out, and like, let's say mod 1, 2, 3, 4, 5, it gives like 2 as a product. But then if I go and divide it, it's going to be different, right? So what do I do in that case? How do mods work? It says I've solved it, but I don't think I have the knowledge to solve this, man. Maybe somebody helps me. Hey, Hector, HSC, what's happening? Thank you so much. Man, I gotta take this ask a question thing down, man. Here we go. Hector HSC. Dang, look at that right there. Okay, so what do I do? Do I just try it, man, and see what happens? I guess so. Not very confident that this is gonna pass. What is happening here? Who put these there, man? Roxanne, welcome to the party. Alright, so this one, yeah, this is what I'm saying. There must be a case like this that exists where you mod the thing and then you divide it and then it's all funky, you know? Alright, let me try and think a little bit. So clearly I can't just multiply everything out because each number could be up to 1 billion and there could be 100,000 of them. So everything's not gonna fit in a long, right? At least I don't think so. Maybe I should just try it to see what's up. Like no way it could work. Like 1 billion. Yeah, it's not gonna. I'm not even gonna try it. How do you do these mods, man? There must be some mod trick. There must be a mod trick, man. Hey, welcome program. World's best LeetCode channel. I don't know about that, man. But it's probably one of the world's longest running LeetCode channels. Maybe not the best one, but I haven't stopped. Hey, Vertazoid. Thank you very much for the Prime subscription. Bumpin'. Oh, Brett, what's happening? I can solve it without division. All right. Let me give it some more thoughts. All right, here we go. Vertazoid, thank you very much. Dumpy Don in the house. It's the best one. Man, I'm trying to be humble, man. Come on, guys. I know it's the best one. All right. You can solve it without division. Yes, I can solve it without division. I think I can. How do you do that? It's like, I know exactly how to do this, man, because I can do this problem in 1D. And how you do it is like prefix product and suffix products. So I can also do this in 2D if I were to translate everything into 1D. So I could apply the same techniques if I did it that way. But I didn't even think about that initially because I was so focused on trying to figure out how the mods worked. But clearly I do not remember about how mods work. But man, I don't know how to translate a 2D into a 1D, but I think I can figure it out. So, what's a mod? A mod is modulo, which is like remainder, how much remainder after you divide. All right, so I'm gonna do some funky stuff here. First, I'm going to convert the array into a 1D array. Man, do I have to do that? And then I'm going to make my new array based on that 1D array. And then I'm going to translate it back to a 2D array. That's my plan. So how do you translate something to a 1D? Should I make a function for that? Maybe. I'll call it 1D or 2-1D. I guess I'll just use whatever they give me as an input, the grid. So I'll make mine, wait, it's a 1D. And what size it is? Of size rows by columns. Can I do like that? Hey, what happened there? Why did it mess up with, it looks weird. But it's okay. I don't even know if I can do that. All right, so what am I trying to do? I'm trying to just iterate through I don't even need to do anything. I can just do it like not a great way, but but this way it will work, right? This is not very fancy way to do it, but I think it's the same thing, kind of, except maybe it'd be better to define. Anyways, I think it's okay. I think it'll be alright, man. It's not ideal. I'll just call it 1D, or I'll call it nums. All right, so what are we gonna do after we do that? Now we gotta make our new thing. I'll call that P or something, because that's what they tell me to call it. No, I'll call it copy or whatever. How am I gonna do this though? I'm just trying to get, ooh, I need a few things. I'll call, this one is going to be my prefix product. And then I'll make another one that's like the suffix. So how do I do that? Let me think. So I think I can just iterate through like so. Oh, jeez. And then nums I, that's the thing, right? Oh, but we have to mod it. One, two, three, four, five. All right, so that's going to be the product, and we want to put this into the prefix. So that's going to be our prefix, and then I want to do the same thing going backwards. N minus 1, I greater than equal to 0, I minus minus. So this is, the first one is going left to right to make the prefix product, and now I reset my product to 1, and then I'm making my suffix product. I can just copy this. And instead of prefix, I'll push it back to this. Oh man. Should I just make this the right size? Because I want this to be, if I push it back, it's going to be like reversed. So I'll do it like that. I'll make it the right size and I'll say the index there is equal to that. So now, if I wanted to multiply something by itself, or if I wanted to get the product of everything besides that number, I'm going to go through and just select, like, let me try and science it out real quick. So if I had these numbers, if I don't know, 2, 3, 7. So the prefix product would be 2, 6, 42. It was 6 times 7, man. Yeah, right, 42. And then the suffix would be 7 would be there. 21 would be there, because 7 times 3 is 21. And then 3 times, wait, yeah, 42. I was about to say, man. So this has been my prefix, and this has been my suffix. And now what I'm doing is, if Zen logic, what's happening? I'm in computer math. All right, so now if we're at this index, and let me put some indices here, 0, 1, 2. So if we're here and we wanted the product of the whole array except this number, it would just be suffix to the right times prefix to the left. Yes. So either I can pad a 1 in the beginning and end, so I don't have to deal with the out of bounds things, or I can just hard code these edge cases at the end. So this would be 1 times 21, and this thing would be 21. Over here, this would be 2 times 7, which is 14. So let's see if that's right. The product of this array of all the numbers except that current index. So it's 2 times 7, right? Yes, that's right. So that's what I'm trying to do here. Hold on. Hey, Steven LF. Sorry, I didn't see your message. I forgot to put my YouTube chat up, man. Welcome to the party. All right, here we go. So what were we doing? We just did this. I'm gonna try, man, should I just do the, should I pad it? Push back. What? Matrices? What you talking about? then if I did that, then I don't know, I might be off by one hair. No, I think it'll be all right, actually. I don't understand what's going on. Well, I don't know how to break it down, but pretty much it's like you're multiplying. So if we're translating the 2D thing to a 1D thing, and then man, I don't know, hold up. Do you want me to explain it, or do you think maybe I'm not sure what to do? So back when software engineering demand was super high, and if you're grinding LeetCode super hard, you get a good job. My question is, if you had a superb memory and just memorize the LeetCode questions and answers, do you think this person can get through interviews? Man, I think if you have a superb memory, for sure. Yeah, I'd say there's a strong chance, especially if you have a superb memory. Because I think after you grinded, I think just by default, by grinding so many LeetCode questions, man, it's like for sure you're gonna pass because you just have that much more practice. That's what I think, at least, especially if you have a superb memory. But I don't think memorizing, like trying to literally memorize every problem is not the way to go. But I do think by doing so many problems, you're just going to pick up on the patterns and you're just going to remember when to use the algorithms in what scenarios, you know? What you need is best view scars, not super memory. I don't know, man. I think all you need is a little bit of practice. And you'll be all right. Anyways, let me try and just finish this problem. So I'm padding with ones on the left and the right side. I just need to make sure I don't get off by ones. So now, did I make my P? Or what? Wait, need battlefield memory? Spookly, what's happening? Seems like it really varies by company. Some put a lot of value on fundamentals, and some of these arbitrary type problems seems a lot more lately. They're doing more project type technical interviews along with system design stuff. Who is they though? I got that weed memory. Yeah, my memory's not that great. Practice with no interview experience can only happen to Simon. Others should get scars. Oh, I see what you're saying. Man, I got lucky, man. I got super lucky. Maybe I got by because I got superb luck. That's what I think. That's the right question. Who are they? We've been asking that since day one. Yeah. Businesses. All right. What was that? All right, we padded the things. Now we have to iterate through and do that multiplication stuff. But man, since we padded it. All right, I don't want to pad it. I don't want to pad it because I'm confusing myself. I'm just going to do it with hard-coded things. So it's going to be like this. If I equals 0, then it's just, wait, what's this thing? Let me do this real quick. Vector int. This is, I'm going to just call it P of size n. So P I would just be equal to suffix I plus 1. If we're at the right end, if I equal n minus 1, then pi will just be prefix I minus 1. Otherwise, oops, then pi is going to be suffix I -1 times prefix I plus 1 mod. Right? And then now we just need to translate that back to 2D. Vector int answer of size rows. And how do you do this? Vector int of size calls. All right, we got to translate this thing back. What are y'all talking about, man? Your corporate overlords, businesses. I need to super lotto numbers, Simon, since you're lucky. Yeah, I don't even play lotto. Unless it's like $1 billion, then maybe I'll buy a ticket. How many digits of pi? I only know 3.1415. That's all I know. The school taught you to memorize pretty much any type of information. What? If you go to Wayback Machine and type pmemory.com, you can get a taste of what they were offering. What are you talking about? All right. We got to translate this dang 1D thing. So how do we translate something, man? We want to translate this thing into 2D. So I know it has something to do with the index. Maybe the row that we're in is going to be I divided by rows. And the column that we're in is going to be I mod calls. Wait, let me think about that, man. That doesn't seem right. This seems way wrong, but let me think. So, let me draw it out, man, because my P brain needs to see something visual. All right, let me use zeros. So these are, so if my I, and let me put this is how it would look if it was a 1D. So 0, I divided by rows. Is that doesn't seem right. So this would be 0, 1, 2. And yeah, there's 3 rows. So then 2 divided by 3 is 0. So that's the right row, yeah? If it was here, 3 divided by, that would be 1. And here, row 2. Yes, so I think R is good. Now C, if we're at index 0. All right, index 1. 3 columns, 2. Yes. All right, we're good. I think this is good, man. Let's see what's up. Nah. It might not be good, but we'll see. What am I doing? Oh, snap. What the heck am I doing, man? How am I gonna get 124? All right, ain't nothing is right here. All right, let me just print my prefixes and my suffixes to make sure I ain't that crazy. I should not just default to printing couts, man. I should just look at my code and see what's wrong, but I don't know what the hell is going on here. 24, yes. And then I hit them with 1 times 12. So how the heck am I gonna get 12 times 12, man? All right, so suffix, oh shit. It's supposed to be suffix I plus 1 and prefix I minus 1. Jesus Christ. I would be slapping in couts. Man, it's not the way though. All right, still something ain't right, man. How the hell do you deal with this part? If it's... There's some mod trick that I need to know. I should have thought about what would happen. And 120, 1, 2, 3, 4, 5 is all right, let me think. I'm thinking like, should I use a different mod and then do, is there some, can I just take the mod of that with 1, 2, 3, 4, 5 with some mod magic or something? Or how do you deal with this case, man? Wait. Because everything is 0 here. Oh, you know why? Because why? I don't know why. Maybe if it's 0. Let me think. Yeah, how do I deal with these? I don't know. I don't know what to do, man. Maybe I read a hint. Yeah, that's what I did though. But how do you deal with weird mods? Do I just... I don't know here. Let me see what y'all saying. Having to handwrite HTML and CSS for a responsive design class? Oh dang, you're in school. Hate design with CSS. Did like half of a computer science degree. Dang, dropped out. I'm stumped, man. I don't feel like I should be stumped here, but I don't know how to deal with this mod thing with 1, 2, 3, 4, 5. Maybe, all right, what I'm thinking is making a much larger mod and then taking the mod at the end. But then I don't know how all that works, so. Should I just Google it? What should I ask? I want to take the mod of something and then Properties of mods. Mods is one of my weakest things, man. All right, so addition. A plus B mod M equal A mod M plus B mod M. Subtraction, multiplication. A times B mod M. All right. Can I use these in any way? If M is a prime number, the inverse of B can be efficiently calculated. I don't know what that is. All right, I give up, man. Brent Arato, what's happened? I give up on this one. Let me see what I did last time, because I don't think I solved this on my own. I mean, it looks almost the same, man. Wait, what did I do differently here, though? So I have my mod. This is my product. Multiply it by that, yes. This is what I'm doing, man. Seems like this is an edge case. I'm not sure. I don't feel like I'm doing anything different here, man. Let me try and submit this. Man, what the hell? What's different in this solution from my solution? I don't get why this works. All right, so this is my product times the current number from left to right, and then I set that there, yeah. And then this one, doing the same. I don't understand. Oh, snap. Wait. I think I see my mistake. Jesus Christ. This should be calls. No, it's still wrong though. Wait, what? Maybe I copied the wrong. Man, maybe I just don't know what the hell I'm doing, man. Oh, I fixed this bug. Though. This is supposed to be prefix here, and this one was supposed to be suffix. Overflow. That's crazy. Well, I understand now. I just had a miscalculation there. Anyways, the problem was not the best for me. What should I do? Should I do a virtual contest? That's what I'm probably gonna do. 4, 6, 7. So maybe I'll do 4, 6, 6. This one right here. Dumpy Don, what's happening? Contest, then we do Elite Room of Mediums. Oh shit. Yeah, let's do that. Alright, minimum operations to equalize array. You are given an integer array nums of length n. In one operation, choose any subarray from L to R and replace each element in that subarray with the bitwise AND of all elements. Return the minimum number of operations required to make all elements of nums equal. Hey, what kind of question is this for a Q1? Paxonian, what's happened? This is a crazy Q1, man. So choose any subarray and take the bitwise AND. Minimum number of operations required to make all elements of nums equal. Should it just be either 1 or 0? Right? I think it's either 1 or 0, man. So if they're all the same, return 0. Otherwise, it's just 1. Q Ultimus, what's poppin'? AI is happening and I'm scared. Yeah, I guess we're all a little scared. All right, Q1 easy. Q2, minimum operations to transform string. You are given a string S consisting of only of lowercase English letters. You can perform the following operation any number of times, including 0. Choose any character C in the string and replace every occurrence of C with the next lowercase letter in the English alphabet. Return the minimum number of operations required to transfer S into a string consisting of only A characters. Note the alphabet is circular, thus A becomes Z, or thus A comes after Z. All right, so minimum number of operations required to transform everything into A's. I can do this. I just need the distance from, I guess, 26. And then, oh, it's every occurrence of that letter. So maybe I should start from B's all the way to Z's. All right, first thing, I think I need a frequency map. And then I will iterate through all the characters in S and increment them in the frequency map. Now, I just want to iterate through, let me see here. from B, which would be equal to I equal 1. I could actually like spell it out. So from B to Z, I guess we add the frequency of that character. And then we have to put the frequency of the next character. C minus A plus 1. All right, I think that should be okay. Oops. Ooh. I'll just do 27 for good luck. All right, 3. Oh, that's not right, man. How's that not 3? That's crazy. I have 3 there. Oh, I see. So we don't need to do this part then. I see how it works, man. But then we also don't even need to do this. It's just like, if it's 1, it's like, I guess I just add everything. All right, should I send this? I don't know, man. Wrong. Anyways, I gotta use the restroom real quick. I'll be right back. All right. Where did I go? I went to the bathroom, man. Oh, shit. I just missed my Type Blazer race. I wasn't fast enough. But, alright, what the heck was I doing, man? Wrong answer. Oh. I see. I see. I had something in there. Anyways, here we go. Three? Man, how am I getting 3 there? I don't know why I had so many silly mistakes on this problem. 2, 0, 25. Jesus Christ. Next question. Count bool subarrays. You're given an integer array nums with distinct elements. A subarray of nums is called a bool if the subarray has at least 3 and the minimum of its 2 ends is strictly greater than the maximum of all elements in between. Dang, let me think. Minimum of its 2 ends. Strictly greater than the maximum of all elements in between. I see what they're saying. So how are we gonna solve this? What am I thinking of? I'm thinking, all right, so the minimum of the ends needs to be bigger than every single element in between them. Okay. So this one says 314, that's a bool array, and 5314. So for sure, whatever the minimum in this array is probably a good place to start looking. I wonder if we should just expand outwards from the smallest. You're attending previous contest, not the last. Wait, what? Don't be done. I'm attending, or I'm doing 466. I think I already did the other one. Cbro or Cbore, what's happening? All right, how are we gonna find this one, man? Have a good live. Thank you very much. 314. 494 was 2 days back. Man, I'm pretty sure I did that. Let me check. I didn't take it live, but I took. Oh yeah. Wait, what's today, man? Today's Monday. You're right. I should have done the one over the weekend that I didn't do. You're absolutely right, Dumpy Don. Alright, but maybe either I'll do it on Wednesday or I'll do it after this. Not sure yet. Brett says this is a nice problem. Alright, I'm thinking sliding window, but I'm not sure when to grow my window, when to shrink my window. I need to try and make some observations here. The first observation that I've been kind of trying to think about is, should I just start from the smallest element and work my way out? But I'm sure there must exist some other subarrays that won't get caught by doing that. I wonder if I can actually just visit all the numbers in order of smallest to largest and then expand from the middle to see how many subarrays I can get. That's another thing I'm thinking of, but I don't know if that's the way I should go. So, alright, the numbers are 10 to the 5th and up to 1 billion every number. Maximum. The minimum of its two ends is greater than the maximum of all elements in between them. Is there... Alright, what else am I thinking? Is there some way to know the maximum number in a subarray in O1 time? Can I use prefix sums to do that? Let me think. Let me think if that's possible. I don't think I've ever done that before. So if I were to keep... Nah, that doesn't make any sense though, right? Because, alright, maximum I've seen thus far, 2, 5, 5, 5, 5. Yeah, that doesn't tell me anything. Alright, let me think. So I was thinking, if I started from the smallest number, and then I'm like, okay, let's see, 314. Yay, 314 works. So how about expand it some more? 5314, that works. Yay. And then expand it some more. And now it doesn't work, so we don't do it there. And then maybe we try 2 next. And then 2, 5, no, that can't work because it's not big enough. 2, 5, 3, that doesn't work. And I guess the moment it doesn't work, let me think. The moment it doesn't work, can you just short circuit? Because if we can't, maybe this idea won't work either. Like, let me try it. So this works. And this works. But what if... Oh, all the things are distinct elements. Maybe that's another hint. Maybe not. Let me see something. If this was, say, 11 instead, like this would be a bool subarray. This would not be. But if it was like this, then expanded one more, this is a bool subarray. So I don't think I can expand from the middle like that. At least it doesn't feel like I can. So let me try and think of other things that I might be able to do here. Minimum of its two ends greater than everything in between. Maybe we can use some type of like monotonic. Hmm. 3. No, I don't know. I don't know what to do, man. I would be panicking right now if it was a real contest. Because I'd have to start digging real deep. This has one trick, but it is nice to practice that trick. All right, let me try and think of everything that I know. I feel like how many people solved it? It feels I should be able to get it if I can make key observations or something. Minimum of its 2 ends is so the big, oh snap. Can I use a map? But when would I, all right, if I did a map sliding window, basically what I'm saying is the top 2 elements must be at the ends. And if I have a window, if that's not true, what do? I grow it? I shrink it? Let's think for a little bit. All right, so 2, 5, 3, the top 2 elements are not. Yeah, maybe that is what I do. So I grow until it's at least a certain size. No. Yeah. At least size 3. And then if the top 2 elements are not at the ends, I shrink it. And then I grow it to size 3. Top 2 elements not at the ends. Oh, but I already missed one right there. So I shrink it. And then I grow it again. And I'll only pick up that if that was my algorithm. So I'll only pick up one of them. What if I did it right to left? Grow it. I already picked up that one. Grow it again. That's 2 going right to left instead of left to right. If I grow it again, that is not good, so I'll start shrinking it. That's not good either, so I shrink it. I don't know if that's, I don't want to waste my time implementing something like that and it turns out it doesn't work. But I can't think of anything else, really. I feel like I need some type of sorting as I'm going through. And I can just check that the top 2 elements are at the ends. Because it's distinct elements, right? Alright, let me try that sliding window map on example 2. So I grow it until here, and we have 5, 1, 2, that's 1. And I grow it some more. That's another one. And then, I mean, I guess it works on this one. And that's 3. Should I just implement? Oh, the answer can be a long, so let me think about that. That means to me that we need to be adding chunks at a time, and it's not just a single one. Oh, so maybe that's a hint. The return type is a long that I didn't see until just now. It's like this one. if you just find the biggest elements, the first and second biggest elements in the array, everything in between those will be something, right? I don't know what to do, man. I just feel like you have to do something in chunks to get to a long answer, right? I use some type of monotonic and get the size of all the elements smaller than it to the left or something. I wonder if it's, let me think about that. So I push 5. No, I'm not sure. I don't know, man. I think I can't think of anything here. Should I peek at Q4? Count binary palindromic numbers. Ooh. Keep thinking about this sliding window. What is... 10 to the 5th. At least 3. I don't know. I wonder if we sort. No, what can sorting do for us? All right, I think I give up, man. I don't know anything. I mean, all right. This is the top 2 elements are at the ends of this thing. So that means everything in between. Man, how has so many people solved this one? Should I give up? It's only been... We got a whole hour left in this contest, though. Let me at least read Q4. Count. Don't give up. Man. You think I should go back don't defense to Q3? Man, I don't like staying stuck for so long, though. I feel like I'm just wasting my time, you know. I think I've thought about everything that I know. Can I binary search something here? I don't know if I can. The long part is dirty. I don't know what that means, Brett. Dirty. You mean it's not true? It can't be a long? It's just a little trick? to throw me off. They made it long because there are many many substrings, but the answer is not a long. I see. Yeah. Brett, that's not, I don't think. I was already ready to give up don't defense. So they tried to trick me. The long part is very good. What do you mean? That threw me off. So their trick works for people like me who try to like reverse engineer the problem based on stuff like that. Because then it doesn't leak info that is actually an int, right? You fell into the trap. I did, man. The signature function should ideally not leak things about solution. Yeah, but it does. At least on LeetCode it does. I know in like a real interview, at least in Google, they don't even give you the function signature, yeah? So, but I've been trying to get hints from stuff like this since the beginning, and I fell into the trap. So it's not a long, it's an int. But how many, like, how am I? All right, one observation I've made, and I don't know how to expand on this, is if I just took the two largest elements and counted how many things in between them, that's how many subarrays, at least that many. But how do I get all the others that aren't from the top two elements? Wait, is that true? It must be, right? Because nothing would be larger than the two largest elements. All right, let me think about that. Two largest elements, 5 and 4, and everything in between them, 1, 2, 3. The answer is 3. Two largest elements, 5 and 4, and everything in between them. There's just two numbers in between them. So that's at least that, but I don't know how to get all the others. That's what I was saying. But I imagine there could be a test case, like, let's say we have, I don't know, I'm gonna just use 9 and then 1, 2, 3, 4, 5, 6, 7, 8. But then what if there's like, you know, I guess those wouldn't be the largest anymore. Hold on. But then if we had something like 79, 78, 77, I don't know, 72, 75. So like I'd only get these subarrays. But I'd miss out on like things like that. So do I just, I don't know what to do. How many interviews have you taken and given? Not that many. Like single digits for both. Can you go back to the top of the problem? Yeah. Here's the problem as well. Wait, am I from Taiwan? I'm not from Taiwan. Jesus Christ. So it must be some type of sliding window, man, right? All right, let me try and slide this window. So all of these would be cool. This would not be cool though. Do I just keep shrinking it until the two largest numbers are at the ends? All right, I don't know. Maybe I should just implement a sliding window and see where it breaks down, because I don't know what else to do really. It's like a sliding window with a map. My sliding window. I'm always embarrassed about my sliding window because I know it's so whack. But it's what I know the best. Whackness. I don't even know what I'm trying to do here. I'm trying to grow my window. Until at least size 3. Is that what I'm trying to do? And if it's at least size 3, then I check this, the left and the rights. And then if that's good, all right, MP R begin. How does that work, man? R begin first? No. Should I call it second? So my big and my second. What do I say, man? If this I don't know, if min right and left, is it the first, I think? It's a little wild looking. Wait, what am I doing, man? I already know what the min and max of these are. This is the big first, yeah. Hold on, I got too many brackets now, parentheses. So the min and this one is equal to second. So that means this is a bool array. Man, I don't know what the hell. But then if this is not true, then I should shrink. Wait. Should I shrink it like this first? I guess this should be ors then. Well, either of those are not true, then I already have the left right there. And then this is weird too, because now let me see, how can I do this? Man, my code is whack. Very whack. This for sure it's not gonna work, man, but I gotta try something, you know. Wait, while what is this saying? Expected. Your observation was very good. Wait, I don't know which observation you're talking about. But it's not right, whatever I'm doing. Alright, okay. I think I see something here. I think I see a bug. So if r minus l, is that gonna be the size? I think I'm adding like like sizes of 2. No, this is wrong completely. Wait, what am I doing? So it continues there, but it doesn't necessarily. I don't know what to do, man. Alright, 5. So it grows to this. Now they're there. That'll be 1. Yeah, that should have been alright, man. R minus L. This, let me just see out. L. Two to 3. I don't think it's doing what I think it's doing, man. Maybe I can be like, I don't know. I don't know, Brett. I think everything is not working right now. Maybe I have bad implementation, maybe faulty logic. For sure, at least both, right? Because I think maybe my implementation is wrong, but also maybe my ideas are wrong too. Use a stack. Oh, a stack did cross my mind, but I don't know. Like monotonic stack type of thing. I don't think I've ever. All right. I have to run in case you're. Yeah. All right, Brett. See you around, man. I will peek because I think I've been stuck on this one for too long. Dang, it's so easy. What the hell, man? Wait, I don't even understand what this is doing yet. So, well, there's something in there. Interesting. Trolling solution? Nah. So you pop everything that's greater than the thing on the stack. So initially there's nothing in here. So then 2 gets appended to the stack. And then we come to the 5. So there's something in the stack. And the current number 5 is greater than 2. So we pop that 2. But then it's not, so then we don't add anything there. And now we put the 5 there. Man, I need to get better with monotonic stacks and queues because I'm really bad with them. So now we're at the 3. There's something in our stack. There's a 5, but this isn't greater, so we don't do any of this. Yeah, I see how it works, man. It's crazy talk. Why didn't I mean, my mind went to monotonic stacks early on, but I just didn't know how to build a solution around monotonic stacks. I think I just need more monotonic stack queue practice. I mean, I could just type up a solution, but I don't think that's gonna help. I'd rather leave this problem unsolved. Anyways, I think that's it for this contest, this virtual one. Hey, don't be done. If you want to do elite rooms, we can do elite rooms. Or if you want me to do the previous virtual contest that I missed, I'm also down to do that one. I'm not sure. Did you take the virtual contest, or did you take the contest over the weekend? A Mohib Fayaz, what's happened? First time here, welcome. I'm just trying to struggle on some LeetCode problems, man. Anyways, I guess I'll do the last contest that I missed. Am I ready for it? Here we go, man. I'm just gonna do it. I thought I already did this, but I did not. My first time doing this contest. Construct uniform parity array, part 1. You're given an array nums1 of n distinct integers. You want to construct another array nums2 of length n such that the elements in nums2 are either all odd or all even. For each index I, you must choose exactly one of the following in any order. nums2i equal nums1, or nums2i is equal to nums1i minus nums1j. Return true if it is possible to construct array such an array, otherwise return false. I want to voice my opinion about this problem, but I'll wait. Yeah, alright, please wait, man. I haven't even read the problem properly. Alright, so either... Alright, there needs to be either all odd or all even. An odd plus an even is an odd. Okay. So, man, do I just return true all the time? Because it's all odd or all even. Like, because if there is an odd, then you can turn that into an even. If we've seen, and you can subtract any index. So as long as, let me think about this edge case now. What if, all right, if it's all odds, then it's okay, right? Because we just choose nums2i equal nums1. If it's all evens, same thing. If we only have one odd or one even, then we can turn, these can be either odd. Don't defense type racer or type blazer. Hold on, let me think about this Q1 first. So we can subtract any index j that's not equal to I. So we can turn all these odds into evens. No. Should I just return true, man? Let me try and think. It's either going to be an even, or if I subtract an odd, it will be an odd. I'm just going to return true, man. Oof. I hope my observation is right. Alright. It is okay. Alright, don't defense. You ready for type blazer? We're going to try the leagues for sure. The official league thing. So, alright, we'll do practice round first. And then we'll do championship race. Let's see if it works, man. Alright. I will... There you are, 5 of us. Let's get it started. This is just the practice round. Don't you worry. Dang, Q first place in the warm-up. All right, don't defense. I added a little rank up here so maybe you can see your position easier with your peripherals, you know. That's very good. Wait, what? Can you please make Alt A delete work? What is Alt A delete, man? Control A delete, you mean? I was like, what the hell is Alt A? All right. Yeah. I think it's, man, I think I did make it work, but if it's not working, I will look into it. All right, that was just the warm-up, man. Here we go. Does Control Backspace work? Maybe. I think I have to make a new race. And I won't put practice mode this time. It is indeed not working. Yeah, clearly, if you're asking for it. But I did something like that for Ricky Wong. And maybe it's not working for, or maybe it stopped working. All right, here we go. Same link, I think. Maybe it's not working now or something. All right, here we go. This is no longer... Wait, we did one without you? Oh, snap, I see. That doesn't count. All right, I think I have to work on that, like UI, user flow and stuff. I don't think it's good. Anyways, ready. This is the real one. Man, I'm so slow. All right, don't defense. 100 WPMs. Very good. 94 for Q. Steven LF 80. I got 76. Clistar 68. All right, let me see how that one works because I guess that one didn't count. The one race you guys did without me, it looks like it didn't. Oh shit, looks like it didn't count for anything. Anyways, we'll work on this tomorrow. I press race again. Yeah, but he said Q won that one, and it was a practice one. Yeah, so either way. But there was like, we did 2 practice races and only one of them showed up, you know? So something ain't right. Why isn't it in recent races? I think because I left the room. And anyways, I'll look into it. Clearly, it's not working the way it should be. But we're gonna get it sorted out, man. Leet Whale, what's happening? How you doing? Anyways, this is just a testing season 2 or whatever until we can get the leaderboards here to work correctly. Which I think we'll get it real soon now that I'm actually using it. Anyways, what problem are we on? Is it this one or this one? No, this is the wrong contest. Man, where's the damn contest at? This one. I had them all open. Why I don't see any games in my race history? Uh-oh. Maybe I broke something. I was messing with it earlier, man. Do I see any games in my race history? I see. Yeah, league games are not showing up right now. Quintero810R, thank you very much for the follow. None of the three, yeah, some of them might not be working clearly. Championship races seem to be working. I did a bunch of changes today, man, so I'm sure I broke something. All I see on mine is hardcore matches. That's what you've been doing? Anyways, let me try this Q2. Construct uniform parity array part 2. You're given an array nums1 of n distinct integers. You want to construct another array nums2 of length n such that the elements in nums2 are either all odd or all even. For each index I, you must choose exactly one of the following in any order. Nums2 I equal nums1 I, or nums2 I equal nums1 I minus nums1 j, where j is not equal I, such that nums I minus nums j is greater than equal to 1. What? What does that mean? Oh, I guess it produces non-zero, non-negative number or something. Was that the same in the first problem? That's a new constraint they've added. Okay. So all we have to do is make sure that there is some number j that we can subtract. Alright, so I guess this time we have to actually solve the problem a little bit differently. Bagel Life. What's happened? K. Welcome. Alright, nums1 is distinct integers. All odd or all even. So basically, maybe I can count how many odds, how many evens, and then just try to either convert all the odds to evens or all the evens to odds and see if this is possible. So as long as all right, if we have all odds, if we're trying to get everything to odds, then as long as we have an even number that's smaller than the odd number, it's okay. And this, all right, I think we can do it, man. So what do we just say? If we're targeting all odds, I just need to make, maybe I just need to track my minimum odd and my minimum even. I don't know if I need to, but I will. So now I'll iterate through all the numbers and I'll say if this is odd and oops, this is even. So minimum, wait, this is odd and this is even. Right? So as long as the minimum odd, wait, let me think a little bit more. Maybe I should also count. I don't think I need to do this, all this crazy stuff, but I don't know what else to do. So if all right, so then now if the minimum odd, wait, let me think. Man, what was I thinking? So if we're trying to get everything to even, like why would it can't just be true again, right? Let me think. Let me think about this case where we have, like, let's say odd, 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 even, odd. But let's say these numbers are 1 through 5, I don't know, 2, 7. So can we make everything odd? We can make this odd if we subtracted that. But if this was 11, we can't make those things. But can we make these by subtracting like, all right, odd, man, an odd minus an other odd gives me an even. But the smallest odd, I can't turn the smallest odd into even. And I can't turn, wait, what's that? Man, I lost my train of thought. I can't turn this into even. But hey, it's already time? That's crazy. Championship race, type blazer. Man, he has already in here. Ricky Wong. All right, let me think about this thing real quick while we're in the type blazer championship race. So all odds not possible. No evens not possible. All right, 11 minus 3. That would give us an even. 3 minus nothing. I can't turn this 3 into an even. But can I turn this? I don't know what I'm trying to think of here. So like, as long as the minimum even is less than the minimum odd. Man, I'm confusing myself, man, this problem. It seems somewhat easy because so many people solved it though. Like, oh shit. Let me do this race real quick. Man, this is crazy. Type them things. All right, there we go. Ricky Wong. Easy. Too easy. All right, geez, let me think about this dang Q2 that I should be able to solve. All right, so I'm just gonna do it one at a time. Can I turn everything into even? So all my even numbers. So if I'm trying to turn everything to even, then I just need to make sure that my minimum if I'm trying to turn everything to even, then I need to make sure that my minimum odd, dang, I don't know what the hell to do. I can't turn everything to even if I have an odd. If my minimum odd is smaller than I can't turn an odd to even, right? All right, try and turn everything to odd. Can I do that? I can turn everything to odd if my minimum even is bigger than my minimum odd. Is that it? I don't know, man. These problems too hard for me these days. True, false, true. Should I send it, man? I'm just gonna send it. All right, that took a lot of brain power to think, and I confused myself so many times. But I should just stick with what I felt, man. I felt this was like that. Anyways, easy clap. No, I spent too much time thinking about that one, Leet Whale. Minimum removals to achieve target XOR. You are given an integer array nums and an integer target. You may remove any number of elements from nums, possibly 0. Return the minimum number of removals required so that the bitwise XOR of the remaining elements equals the target. If it is impossible to achieve target, return -1. What? So, remove any elements, return the minimum number of removals so that equals to the target. So bitwise XOR means that only, man, lots of parity in this contest. Bitwise XOR means that only bits that count positive or count odd will be turned on. So, dang, so many people solve this one. It's crazy talk. So given the target, the bitwise XOR of everything, I guess I should count all the bits and then see. Man, this problem seems there must, oh dang, maybe that's why the constraints are so small. Only 40 numbers, man. It's crazy. So I think I need to count all my bits. Wait, do I need to count all my bits, man? Do I just take it or leave it on every single index? And then I take the maximum number of elements that I took. To equal the target, and I minus the original number of elements minus the maximum elements. J. Pedrine Pontes, what's happened? What type of project am I working on? I'm doing LeetCode, just algorithm problems. All right, I think I'm just gonna do a take it or leave it for this. Do you have Claude working on anything? Not right now. Let's see. Take it or leave it. And then, all right, so if we are out of bounds, then what? I don't know what. Can I just, is it take it or leave it? Or is it something else? Fair limit, you should be abusing it. Man, I guess in the beginning I tried to like always be making Claude do something, but I think that's detrimental to my mental health, man. So I don't have it do that, and I feel like anytime I make it do things overnight, it's always a bunch of slop. But my usage, man, I need to try to not burn my tokens, because like I'm already almost 50% of my usage, and I got like 4 more days left in the week for me. So at this rate, I'm gonna hit my limit unless I slow down. And I haven't really, so like if I tried to make Claude be working 24/7 for me, I would definitely need another plan or subscription. All right. I don't know if it's a take it or a leave it, man. Because if I took something, oh, well, if I took something, I should just XOR the thing, right? All right, so -1 billion is probably okay here. All right, so I'm taking it or I'm leaving it. And then for every index, we make those choices, take or leave. So if we took it, that would be this XOR by nums I. No. This would be 1 plus dp I plus 1. And then we do that. If we left it, it would be yeah, and then we just return the maximum. And then I cache that. Anyways, I should get 1, -1, 0. 1. Ooh, mistake. All right, we should have 1. What are you talking about, man? Maybe I should return int max instead. I think that not understand. Okay, I'm not speaking like English. Starting. Hey, if you're just starting to program, man, I don't think this is where you start at. This is more for people that know how to program already, I'd say. Wait, what? Why is it so? I'm returning. Oh. I should be able to get this problem, I think. But you never know. All right, 1, -1, 0. Oof. So maybe this should be min, man. Jeez. And then this should be like, if it's less than something, then it's bad. 2. N minus 2. All right, 1, -1, and 0. All right, should I send this? No, I need to cache this first. So I guess we can cache on like this of size n, and this one of size 10,005 or something. Zero, -1, 1. I'm just gonna submit. Ugh, come on, man. Come on. What the heck is this? How's it gonna overflow, man? There's like one test case where they made it overflow. How's that possible? What the heck is going on, man? Isn't like Do I have to go n plus 1 for good luck? Jesus. It's not n plus 1 for good luck. So how the hell is this number gonna get that big? Oh, I see. Because, all right, 10 to the fourth. What's that? 10 to the fourth. 10,000, right? So which bits is that equal to? I don't know. What's 2 to the 10? 11, 12, 13, 14. I mean, I see what's happening, man. I need to set everything 2 to the 13. Two to the 14. I guess I need to have bits up to like 16,000 or something. I'm gonna change this to 17. I'm gonna change it to 40,000 just to be extra good luck. And it doesn't tell me what the answer should be, but I'm submit this, see what happens. All right, Q3, not bad. I made a mistake calculating the size of the cache that I needed. All right, can I get Q4? Count good subarrays. You're given an integer array nums. A subarray is called good if the bitwise OR of all its elements is equal to at least one element present in that subarray. Return the number of good subarrays in nums. Here, the bitwise OR of two integers a and b is denoted by a or b. Let me think. So, how many good subarrays? A subarray is called good. Bitwise OR of all of its elements is equal to at least one element present in that subarray. So we need a number with all the bits set to all right, so each number itself is one good subarray. And then basically dang. I don't know what to do actually. Mm, 10 to the 5th. Every index itself is 1. How do I know that this is 1? I don't know. I don't think I have the juice to solve this one, man. What do I have to do with these bits? So when I do a bitwise OR, we can only turn on more bits. We can never turn off bits. And then we just need to find a number that has all the bits set in that subarray. Like 3 in binary is 1, 1. 2 in binary is 1, 0. I'm not sure what to do here. One, 3, 1. Maybe it has something to do with the highest and lowest power of 2 in that subarray. Those are the bits that we need set. I don't know. Too hard, man. Dang, 3,500. Not great. Anyways, everyone's bumping. I guess this contest, Q1, Q2, Q3, not so bad. Q4, a little bit too hard for me. Unless, should I look up this answer? I will. Hint 1. Observe that a subarray is good if its bitwise OR equals its maximum elements. And did not make that observation. But it makes sense because the OR of everything is going to have all the bits set. So if all the bits are set, then that's probably the maximum element in that subarray. Dang, monotonic. Never even thought about monotonic. Anyways, I gotta practice more monotonics, but not tonight, man. Tonight, maybe that's it. Maybe my monkey brain is too tired to do any more LeetCode. Should I go raid? Get out of here. Nobody does LeetCode anymore, man. Pat not streaming. Chi Impact, I haven't seen stream LeetCode, but I seen him stream Slay the Spire. Job hunting. This guy's doing LeetCode. Oh, he has a nice chair. Look at that. Herman Miller. Dang, look at that massage chair. Alright, we're gonna go raid this guy, and I'm out of here, man. Anyways, see you guys next time. Leet Whale, adios. I'll see you next stream, next algorithm stream. I guess I'll be on tomorrow. Ending early? Yeah, man, I'm tired of this LeetCode nonsense, man. Done enough problems. Brain is tired, man. So I'll be on tomorrow for type blazing. And hey, I've started on those passages don't defense, so maybe we'll get some of those passages in tomorrow. All right, this guy, Hot Latte Ice Americano. He says he's grinding LeetCode and looking for a job. Maybe Type Racer is dead already? What do you mean? Anyways, I gotta go. Don't defense. I'll see you tomorrow, maybe. And Leet Whale, Vermeil, adios. Q Ultimus, Bagel Life, see you later. And who else? Dumpy Don. Anybody else who's lurking? I mean, we probably did our last Type Racer. All right, everyone from YouTube, also take care. Adios.